Alright, 26, you should have gotten G from Friday. Does anybody need me to go over 26? Yeah? Okay, so you got to be careful what it asks. It wants you to add that number to both the top and the bottom, okay? So if you add, well, really subtract 5 to 7 and subtract 5 to 9. So what's 7 minus 5? 2, and what's 9 minus 5? And what's that reduced to? 1/2, which is what they wanted you to get. If you do the 11, you'll get 2 over 1, which is 2, not 1 over 2. All right, 27, you should have gotten B. Does anybody need me to go over 27? Anybody need 27? 27 going once? Yeah?
What is that equal to the? No, I mean it's not equal.
It's not equal, yep. So pretty much you know that A has to be bigger than B. So you know that they can never be equal. Well, if they can never be equal, the logical choice is that they are not equal, which is B. I can prove that the other ones are not true, but that's just the most logical, quick way. All right, 28. 28 should have been J. I had to do is find the slope. Do I need to go over that one? Yeah? All right, so to find the slope, what letter do you have to solve for? Y. But the easiest thing to do is just add that Y over to make it by itself. So that would be positive 11y. And then how would you get y by itself? Divide by 11. Okay, which one is the slope? Now that y is by itself, is the 14 over 11 or the 11 over 16?
16 over 11. The 14.
Because the x is with it. Whatever's with the x is your slope. So it's 14 over 11, which is J. All right, 29 is what we are starting with chapter 7 today, which should have been B. And we'll go over how to do that stuff this week right there. All right, and then 30. Let's see, 30 should have been H. Does anybody need me to go over 30? Yeah? Okay, so do you see these two triangles right here, this one and this one? Okay, well, guys, how much does a triangle add to B?
360. No, 180.
180, right? Okay, both those triangles already have a 90, which means that both of these angles have no choice but to be what together? 45, 45, which together is how much? 90, which is what they would add to B. Okay. All right, we'll do the rest after announcements.
Here's your daily play and $2 to enter. Get your team 30.
Alright, so let's look down at the bottom. So where do you go first if you want to graph something, guys? Go to y equals on your calculator, which is right here. My finger's still there if you need it. Alright, and then we're just going to type this in. We're going to type in 2, and then to hit a power, remember it's the little arrow button, the caret, right below the clear button. And then you just hit X. Remember, X was right next to the green button. And then you should graph. It's pretty easy stuff. Alright, so my calculator is in color. So let me zoom it in so you can see it. If you've got your own calculator, yours may be in color too. But do you see how you can see that blue overlapping the X-axis right here? So your calculator, if it's in black and white, then you're not going to be able to see that. So yours is just going to look like it starts from here, but it really doesn't. It's getting really, 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 really close to the X-axis. So, yeah, it looks like it stops, but it really doesn't. All right, so now you can tell your calculator to give you a set of ordered pairs so that you can graph all of that. So you go to table. What do you have to hit first, though? Second, and then table, or second and graph, whatever you want to call it.
0.
All right, so what do we have? We have 0 and 1, you said? Okay. What else do we have? 1 and 2. 2 and 4. 4. What else do we have? We have 3 and 8. 6, 8. And then the rest of them are too big, right? Okay, guys, these are called exponential graphs because they grow exponentially. Like, they start really, really small, but then all of a sudden when they start growing, they just shoot straight up, okay? So we've got to do some points on the other side as well. So what about -1? Where was the point with -1?
0.5.
0.5, so it's right there in the middle. And what about -2?
0.25.
Okay, so it's getting closer and closer and closer to the x-axis, but it never crosses over it, okay? So let's talk about money. You've got money that's in the bank account, right? Your money starts at what number before you put anything in there? 0, right? So it's never going to go below 0 as long as you are not taking money out. But what you're hoping is that you're putting money in and the bank is putting money in. So guys, if you put your money in the bank, what did they give you in return? Interest, right? So if you put your money in a savings account, you're going to get a little tiny bit of interest. If you put your money in a CD account, which is where you can't touch it for like 6 months or 9 months or 12 months, whatever you do your CD on, then you get more interest. So they'll give you interest just for putting their money in the bank. So why do they give you interest back because you put your money in the bank? Like, what's the point of them paying you money back?
They use it as stock.
They use it to do what?
They buy stock and they stock.
Not with stock. What happens when you want to buy a car? Who do you go to? You go to the bank and you take out a loan, right? They use that money, which is why, like, back in the day, whenever the stock markets crashed, nobody had any money because they had loaned everything out for houses and cars and everything else. So that's why they give you money, so that way they can use your money for that stuff. So here you go. Connect all your dots, but do not let it go below the x-axis, okay? Do not let it go below the x-axis. It does not cross over. Pretty easy, right? All right, let's go to number 2. Let's go to number 2. Let's do all these first, and then we'll do domain and range. All right, so go back to y equals, clear it out. All right, now you got to be careful. You have to use parentheses just like they use parentheses, okay? Bless you. 1 divided by 4. Close your parentheses, bless you. Make sure you close your parentheses first, bless you. Yes?
On the next two graph, if it had this like an unlimited y-axis, would it eventually get straight up where forward?
It will look like that, but it won't actually be straight up. It'll be like microscopically getting closer. But yeah. All right, so then we hit graph. Okay, what do you notice about this one? This one's different. Bless you.
It's on the negative side.
It's on what side?
Negative side.
Well, the other one went on the negative side.
Well,
See?
why did the
Look at the picture. What's different about these two? Anybody? What's different about 1 versus 2? What, Jonathan?
It's going to the left.
It's going the opposite way, right? This one went up to the right. This one goes up to the left. All right, so here we go. Where do we go first? Table. So second table. All right, let's see. Where can we start at? Down here? Well, we can start way before that. We can do 1 and 0.25. We can do 0 and 1. Then we can do -1, 4. That's the only one we can fit on there, right? -2 is 16, way up there. All right, so then you connect the dots. If you're left-handed, this one's easier for you to do. But when you connect them, it does not go below what?
the line?
The x-axis, right? Don't curve it back up. Don't curve it down. It just rides right along that x-axis, okay? Pretty easy stuff. Let's go to the last one. Y equals, clear it out. All right, this is where you got to be careful. You ready? So you type in your 3, hit your arrow button, and then it's x plus 2. Now, if you have the older calculator, if yours pops up a parentheses instead of putting it up here, you have to close your parentheses after the 2 if yours is like that. Does anybody have one like that?
then here's just got this extra piece of but that doesn't cover only this piece right here. Okay, and then you can hit the, what is it, subtract 2? Make sure you hit the subtract 2.
And not the negative 2. And then hit graph. Okay, what do you notice about this one? Bless you.
But it's not on the X.
It's not on the x-axis. Where is it level with this time? Negative 2. What moved it down to? The minus 2 in the back. There you go. Alright, so then we can hit graph. Alright, so we've got, let's see, we got negative 2, negative 1. We've got negative 1, positive 1. 0, 7. And if we go the other way, they're just going to get really, really close. If I go the other way, they're going to get really, really close to what number, but never cross over it?
The y-axis.
No. What number is it getting close to this time? Negative 1.667, negative 1.889, negative 1.963, how much? Negative 2. It's going to get real, real close to negative 2, but it is never going to cross over. So right here, it's going to get right there close to negative 2. It's just going to ride right along negative 2. It doesn't curve back up. It doesn't curve back down, okay? Are y'all okay with these? Pretty easy? Huh? No, really that. This stuff's pretty easy. Until we get to, after spring break, it's a little harder, yeah. Okay, here we go. Growth or decay. So look at number 1. Does that look like a growth or does that look like a decay? Growth. Very good. Make sure you write the word growth. Alright, what about number 2? Does that look like a growth or decay? Decay, because this one's going down, right? Okay, what about number 3? Growth or decay? Growth. Very good, because it's going up. You read it just like you read a book, from left to right. Okay, then we've got to do domain and range. Remember doing that a while back? Domain and range. The cool thing is domain is always the same. Where does domain go? From which way to which way? Left to right. Well, very good. Okay, so on the left, where is it going forever and forever and forever and forever to the left? Negative infinity. And to the right, slowly but surely, where is it going to the right? Positive infinity. There you go, bless you. Same thing on the left, on the number 2. Where is it going to the left? Negative infinity. Where's it going to the right? Positive infinity. Number 3. Where is it going to the left? To the left? Negative infinity. And then to the right, slowly? Positive infinity. Leslie, very good. Y'all okay so far? So on these graphs, they're always going to be negative infinity, positive infinity. All right, Blake? All right. All right, what about range? Range is from where to where? What was that song? Starting from the bottom, right? From the bottom, where is it getting closer and closer and closer and closer to? Does it ever actually going to hit 0? Nope. So what do we use if it doesn't hit it? Parentheses. Very good. All right, and where is it going up to? Positive infinity. There you go. Alright, you got to be careful, guys, on range. Range is where? Where do I start? At the bottom. Where is it getting closer and closer and closer to at the bottom? 0. Doesn't hit it? There you go, so it gets parentheses. And then where does it go up to? Up to. Up is positive. Very good.
And then this one's like, let's see,
-2 is where that one gets close to. Very good. And where's that one go up to? Positive infinity. Are y'all okay? Congratulations, you just did all of 7.1 in like 10 minutes. Sweet. Y'all okay with that? Pretty easy stuff? Alright, flip over to the back. Let's do section 7.2. I wouldn't throw all this stuff at you if it wasn't pretty easy. After spring break, it gets a little bit more in-depth, but right now it's pretty easy. Okay, do you remember all those perfect squares that we just did? Gotta know them again. What's the first perfect square? 1. What's the next one? 4. Keep going. 16. Yep. Yep.
56.
Uh-huh.
49.
Yep.
56.
Nope.
No, 64.
Yep.
72.
Nope.
81.
Mm-hmm.
100.
Yeah, it's good enough for right now. Okay, here we go. You have to make these have the same base, okay? So look at 4 and 64. Can I put 64 to be 4 to some power? Is there 4 to a power that gives you 64? So let's use your calculator. You ready? So let's do 4 to the second. What's 4 to the second?
16.
Okay, all right, that's not 64. Let's do 4 to the third. Oh, there we go. So instead of writing 64, what can I say instead of 64 that means the exact same thing? 4 to the third, not 4 times 3, 4 to the third. Yep, 4 times 4 times 4. Okay, guys, now look, once you get their bases that are the same, you can set their powers equal. So what are their powers? And 3. So 2n minus 1 equals 3. And how could I solve that for n? Add the 1. And so 2n equals 4. And then what? Divide by 2. And what's n equal? 2. There you go. Alright, plug it in and check it. Plug it in. What's 2 times 2?
4.
And what's 4 minus... That's right, 4. And what's 4 minus 1? 3. What was 4 to the third again? 64. There you go. All right. 22. Look at 2. Look at the bigger number, 27. All right, 3. Can I make 3 to some power give me 27? So let's see. 3 to the second is 9. What about, what's the next one I could do? 3 to what power? 3 to the third. Oh, look at there. 27. So instead of 27, I can write 3 to the third. So I've got 3 to the 5x equals 27 was 3 to the third, right? Y'all okay with that? Okay, but look right here. You can't forget this extra stuff that's there. So you're going to take all that extra stuff, 2x minus 4, and you're going to multiply it by 3. So you just put parentheses around it. Okay, do they have the same base now? Yeah, so you just set them equal. 5x equals 3 parentheses 2x minus 4. Okay, what could I do to solve that for x? There you go, distribute the 3. So that'd be 5x equals 6x minus 12. What else could I do?
Subtract the 6.
There you go. Subtract the 6x. That would be negative 1x equals, don't forget that negative with that 12.
That's x equals 12.
There you go. Divide by negative 1. X equals positive 12. Very good. Very good. Okay, if you want to check it, here we go. Plug in 12. What's 5 times 12? 60. So 3 to the 60 is quite a large number. All right, let's plug in this one. What's 12 times 2? 24. And what's 24 minus 4? 20. So 27 to the 20. Do those numbers match up? Yep, there you go. So you got the right answer. All right, let's look at number 3. Here we go. Look at the bigger number. Can I rewrite 7 to some power to give me 49? Yes, 7 to what power? Huh? Squared. Very good. 7 squared is 49. But then you have to take the piece that was with 49 and put it in parentheses. There you go. All right, do they have the same base now? All right, so you set their exponents equal. 2 parentheses x plus 5 equals 8x minus 6. Okay, do what? Distribute the 2. Yep. So 2x plus 10 equals 8x minus 6. What could you do from there? Well, which one are we moving? Are you moving the 6 or are you moving the 10? You want to move the 10? Okay. Okay. So 2x equals 8x minus 16. So then we had to move the 8. So negative 6x equals negative 16. Divide by negative 6. Okay, then negatives cancel. All right, 16 and 6 doesn't divide, guys. But what number goes into 16 and 6? 2. So 16 divided by 2 is 8. 6 divided by 2 is 3. You should get a decimal. Y'all okay? Not too bad, right? Hopefully. All right, let's look at number 4. Number 4, here we go. So look at this right here. How do you rewrite a number that's on the bottom? Like, I can move that 64 to the top, but what does his exponent become when you move it to the opposite position? So if I were to rewrite that as a 64, not a 1 over 64, just as a 64, what does his exponent have to be? What kind of 1? Negative 1. Very good. Remember, when you move it to the top, it changes signs. If you move it to the bottom, it changes signs. All right, look at 64. We already did this earlier. I can rewrite 64 as 4 to what power? To the 3rd. Very good. And then you just multiply it by that negative 1. All right, since they have the same base, we'll set them equal. 2x minus 5 equals 3 times negative 1 is negative 3. All right, what could I do first? Add the 5. There you go. So that gives you 2x equals positive 2. And then you can divide by 2, and what do you get? Positive 1. There you go. All right, I want y'all to try number 5 real quick. Try number 5 on your own. All right, did y'all get 2 as an answer? So did you do 3 to the 2nd was 9? Did you do 3 to the 3rd was 27? Okay, all right, just look at it. No? All right, guys, the bottom down there is your homework. It's the combination of both things together that we just did. So if you want to go ahead and get started on it, you've got about 10 minutes. It'll be your first homework assignment, so please make sure you turn it in, okay? It'll be your first homework assignment.